Hi everyone. In this video I will be solving economic load dispatch problems. In the economic load dispatch problem we are finding the economical power generation and the rupees we are saving in economic generation scheduling. Let us consider this example. So here they are given incremental fuel cost in rupees per megawatt hour of two power plants. dC1 by dP1 is the incremental fuel cost of the first plant, that is 0.1 P1 plus 40, and for second generation equal to 0.25 P2 plus 30 rupees per megawatt hour. The total demand is 150 megawatts. Here the question is we have to find how the load is shared between the two units. How the load is shared between the two units economically. And we have to find the incremental fuel cost and also how many rupees we are saving when we go for economic generation. See here economic generation means we are finding the generation of each unit so that the cost of operation should be minimum, and we have to meet the condition that the total generation should meet the demand. So the question here is, the first question here is we have to find the power output from the two units, and the second thing is we have to find the incremental fuel cost of the system, and the third question is we have to find how many rupees we will save. To find this answer, let us consider the condition for economic load dispatch. Here in this problem they are not talking about the incremental transmission losses. So transmission losses here we are neglecting. So considering this, for economic operation, the condition for economic operation is dC1 by dP1 is equal to dC2 by dP2, and this is equal to lambda. This is the condition for economic operation. Here they are given the incremental fuel cost equations. So the two unknowns, two equations we need. So that means if you equate this dC1 by dP1, we will get 0.2 P1 plus 40 is equal to 0.25 P2 plus 30. This is equation 1, and the condition for the equality constraint is equal to PD. The generation, sum of the generation should be equal to the demand. The demand is 150 megawatts. The demand is 150 megawatts. So this is equation 2. So here we have to solve 1 and 2 for P1 and P2. For P1 and P2. So by solving those two equations, we will get P1 is equal to 61.11 megawatts, and second generation is 88.89 megawatts. When you add this, you will get 150 megawatts. And the second question is we have to find the lambda. Lambda is nothing but the incremental fuel cost that is given by the equation. So here any of the incremental cost equation let us consider, like first one dC1 by dP1 we have 0.2 P1 plus 40, it is given. So P1 is known, so that lambda is equal to 0.2 P1 plus 40. So P1 is known, that is 61.11. If you substitute, you will get lambda is 52.22 rupees per megawatt hour. So this is lambda. So then now the third question is we have to find the saving in rupees per hour when you compare the two costs. One is what is the total cost for equal load sharing and what is the total cost for economic load scheduling. So equal load sharing means we have P1, we have P2. So equal, both the generators should take the half of the load. So that is 150 megawatt is the load. So divided by 2 is 75 megawatt. 75 megawatt. So here for equal load sharing this is. For economic we know what is P1 and what is P2. It is here. So we have to find the cost equation. In that cost equation, if you substitute for P1 and P2, we will get the final answer. So that can be done like this. So we have the incremental cost equation, that is dC1 by dP1, dC1 by dP1 we have, that is given by 0.2 P1 plus 40. We want C1. So how to get C1? We have to take the integration on both sides. So C1 is equal to 0.2 P1 square by 2 plus 40 P1 plus some constant. Similarly, we have the second equation, that is dC2 by dP2 they have given, that is 0.25 P2 plus 30. So if you integrate on both LHS and RHS, you will get C2 is equal to cost equation for second unit, that is 0.25 P2 square by 2 plus 30 P1 plus D1. So this is equation 1, equation 2. So here what we have to do is, in the previous slide it is shown that FT cost and this is there, no, FT equals, so we have to substitute. So the saving is equal to FT equal load sharing, what is the cost, and economic load scheduling, what is the cost. So here FT is equal to, that is a total cost, that is C1 plus C2, here C1 plus C2. Here in the equal load sharing, P1 and P2 values are the 75 megawatts, that you have to substitute. So here C1 is equation is there, C2 equation is there. So here P1 and P2 value we have to consider it as 75 megawatts, both are same, equal load sharing, 75. Here P1 is, we found that P1 value it is 61.11 megawatts and P2 is 88.89 megawatts. That means I will show you here, it is found, yeah, these are the values we have to substitute for economic load scheduling. So formulas are there for C1, C2 is there, C1 is there, C2 is there. Here C1 and C2 formula, it requires P1 and P2 values. You have to consider in equal load sharing 75 megawatts. In C1 and C2 formulas, in the second term, you have to consider P1 and P2 values as this. So if you substitute, you will get the saving is equal to, the answer here is, you will get 43.4 rupees per hour. Suppose if you want to find it for year, so we have to multiply with number of hours in a year, that is 8760 hours per year. This is rupees. So the rupees you can save is 380184. 38 3,80,000 3,80,184 rupees we can save when we go for economic generation scheduling. I think you understood this Once again, I'll add the recap. So they will be giving two incremental cost equations and the total demand. They are asking us to find the values of the economic generation, lambda, incremental fuel cost, and how many rupees you will save. For that, we have this condition for economic load dispatch. So with this condition, we have to equate the incremental fuel cost of two equations, and we know the equality constraint that P1 and P2 both the generation should be equal to, when you add them, that should be equal to PD. So two equations, two unknowns, you can find P1 and P2. Thereafter, we have this condition. So in this, I have substitute for the dC1 by dP1. Here we have find the lambda value. P1 is already known, 61.11 megawatts. If you substitute, you will get lambda value, that is incremental fuel cost. After that, we have to save the rupees when you compare equal load sharing and economic load sharing. So equal load sharing means the total demand on the system is divided equally among the different units in a generator. Suppose two units in a plant, suppose load is 150 megawatt, 150 divided by number of units, that is 2. So you will get 75 megawatts. So economic load scheduling means we know P1 and P2. So by having the cost equations, here we have the cost equations, incremental cost equations. They are given this. First integrate it, you will get C1, you will get one constant, here one constant. When you take the difference, so here D1 plus D2 here you will get. So here also D1 plus D2 you will get. So plus minus they get cancelled, you will have only the values. Okay, this is how we can find the rupees you can save. So next one more typical problem. This is university question, paper question. In this, the question here is, they are given the fuel input in calories per hour. Fuel input in calories per hour in each unit in a plant. So in a plant, if you have two units, the first one fuel input in calories per hour, that is 8P1 plus 0.024 P1 square plus 80 into 10 to the power of 6. These are the equation. And also the cost of the fuel is rupees 10 per million calories. Rupees 10 per million calories. Million means 10 to the power of 6. Determine the minimum cost of generation per day if the load curve is as shown. Here the load curve is shown is the variation of load with respect to time. Actually it is given for 24 hours. So 6 hours, 6 fours are 24 hours. So they are given for a day. See here from 12 midnight to 6 am, 12 pm to 6 am, the load is 150 megawatts. Again from 6 am to 6 pm, that is 12 hours. Here 12 hours, here only 6 hours. Here the load is 150 megawatt. And here load again come to 50 megawatts from 6 pm to 12 midnight. Again here we have a 6 hours slot. So for 24 hours, the load is distributed like this. It understood here is that in 12 hours, the load is 150 megawatt load demand. In next to 12 hours, the load is 50 megawatt. So the demand, the load demand is 150 megawatt and 50 megawatt. For first 12 hours, okay, 150 megawatt. Next 12 hours, 50 megawatt. The load is varying in two slots. So irrespective of the time, in a 24 hour, 12 hour is 150 megawatt and 12 hour is 50 megawatts we understood here. And also it is given that the maximum and minimum loads on units are 100 megawatts and 10 megawatts. That means your generation power should be within this range. It should be less than 100 megawatts and it should be greater than 10 megawatts. This information is also given. So first what we have to do here is the fuel input equation is there, no, in calories per hour. So let us convert that into rupees per hour. So this can be done like this. So let us erase this. They have given rupees 10 for million calories. They have given this. For that, we are considering that in F1 equation. See, F1 equation here, F1 equation, it is in calories per hour. So if you multiply calories per hour with 10 calories per 10 rupees per million calories. Actually, this is 10 to the power of 6 calories per hour they are given, rupees 10 per million calories. So here 10 to the power of 6, 10 to the power of 6 get cancelled. So this F1 equation, whatever it is there, that equation if you multiply with 10, you will get rupees per hour, rupees per hour. So example, here F1 is equal to 8 becomes 80. You are multiplying with 10. So 80 P1 plus 0.024 into 10. So if you do that, you will get 0.24. 0.24 P1 square plus 800. This is rupees per hour. Similarly, you will get F2 is equal to 60 P2 plus 0.4 P2 square plus 1200 rupees per hour. So once you know the values of F1 and F2, you find the incremental fuel cost. So you will get 80 plus 0.48 P1. This is one incremental cost. The F2 equation, if you take the differentiation with respect to the second plant, so you will get 60 plus 0.8 P2, second equation. So here in this problem it is not given any transmission losses. Therefore, what we have to do is the condition for incremental fuel cost. See here, this should be same like previous problem. Here the incremental fuel cost are same for both the plants. Again, in this problem, it is taken that, see here, DC1, DC2 equation is there, now you equate. So you will get 80 plus 0.48 P1 is equal to 60 plus 0.8 P2. Okay, this is one equation, third equation you can call. Again, P1 plus P2 is equal to PD. Here the demand here is for 12 hours 150 megawatt, and in the other 12 hours it is 50 megawatts. So we have to consider PD 150 megawatt once, and then we have to find P1 and P2. Next we have to take the PD as 50 megawatt, we have to find the P1 and P2. Two times we have to do the calculations. Why? Because load is different in 24-hour slab. So we have two equations. This is 3 and 4. Two equations, two unknowns. We have to find P1 max. Let us take, this is P1 minimum. That means the load is maximum, the economic generation is P1 capital letter M, P2 capital letter M. When the load is minimum, P1M, P2M. This is how we can solve the problem. So if you simplify, you will get P2 is equal to 0.6 P1 plus 25. This first equation you can call. Again, P1 is equal to 1 divided by 1.6 PD minus 25. This is the second equation. So here the demand is 50 megawatts. Here the demand is 150 megawatts. So when load is 50 megawatts, P1 is 50 small m. P2 small m. The answer here is, you can cross verify, megawatt, and then 34.375 megawatt. When the load is max, P2 max, when the load is 150 megawatt, then the answer is 78.125, here 71.875 megawatt. Okay, this is how we can do the problem. Just two equations, two unknowns. PD value you are changing to 50 megawatt or 150 megawatt. Correspondingly, you are finding the P1 minimum, P2 minimum, P1 maximum, P2 maximum. These are very simple. Two equations, two unknowns. PD value you have to take two different. So this is how we can find the economic generation at different loads. So if you want to find the cost for this, so we have F1 equation and F2 equation. So if you substitute P1 and P2 value as this, you will get F1m small letter m. Similarly, we have F1 equation, F2 equation. P1 and P2 values, if you substitute this, you will get the maximum generation cost. So when you add these together, you will get the total cost per day. Total cost per day. The final answer you will get 263850 rupees per hour. So this is how you can find the total cost when we have a load curve of such here is a load curve. So in this lab, total load is changing. Maximum is 150 megawatt as it is clearly given. Minimum is this. That means 50 megawatt is there for two slabs, that is 6 hours, 6 hours, 12 hours. You have to find that. Next again here you have to find. So you have to find like this. So the answer whatever you are getting here, you should multiply with 12 hours. Here whatever the answer you are getting, multiply with 12 hours. So thereby you will get this answer. So I think you understood this. With this I will be ending this video. Thank you. Thank you one and all.